Hi guys and girls on YouTube, and welcome to my channel. We've got a few days coming up for the bank holiday that I'm going to have a little bit of time off work. So I thought what I'm going to do is when I'm at home, I'm going to do another radio restoration. But this time I'm going to take this radio to the next level restoration. So let's just, I'll move the camera over and we'll just take a look at the radio. Now I know what you're thinking, I've already done one of these particular radios before. But we're going to go a bit overkill on this. So the case needs a bit of work. The front needs repainting. You can see where it's worn off, where somebody's turned the control. The Phillips badge is missing. Let's just have a look in the back first. Now this is of course the Phillips B2G81U. There's quite a lot of these about. Like I say, I've already restored one in a previous video, but let's just take a look inside this and let's have a look at one or two of the common problems. Right, so as you can see inside, it's very, very dirty. I would imagine that this has had nothing whatsoever done to it. It might have had a valve change. I don't know if they're original. I really don't know, but you can see it's very, very dirty. Now I'm not a big fan of spoiling originality, but on this we're going to completely spoil originality. We're going to go overboard. Now one of the most common problems on these is actually this circuit board, and it's made out of a material called SRBP, which I believe stands for synthetic resin bonded paper. Now the problem with this is once you heat it, it becomes electrically conductive, and especially around this sound output valve, what happens is the board, it actually chars and it becomes electrically conductive, and you get a humming in the speaker. So the plan is, what I'm going to do is I'm going to get this radio actually basically working, or plug it in, and if it works, it works. If it doesn't, I'll fix whatever fault's on it. And then I'm going to completely strip every single part of this circuit board, and we're going to make a brand new circuit board with FR4 fiberglass, which is a lot more heat resistant and a lot more durable than SRBP. So that's the plan. Let me just get now I'm not sure, I don't know about these valve holders. I don't know whether to replace them or just ultrasonically clean them. I might ultrasonically clean them first, because I'll tell you about these valve holes in a minute. These are rather special, and it's not, well, you can't really just fit any, but we'll come to that in a minute. So let's just take a look at the new circuit board I'm going to be using first. That's the UCL82 sound output valve. Right, so here's the plan. I've got the service manual for this radio, so it's not going to be a big deal. I'm going to take every single part off this board. We're going to make a new circuit board, and then I'm not sure whether to put these dog bone capacitors back on. I might ultrasonically clean them, put them back on, because these I've found in the past they're very, very reliable. The resistors I'm going to change every one, because as you can see they're 10%, and the carbon anyway, so they've probably risen in value. The electrolytic, I might keep that and refill the can with some new electrolytics, or I might put a modern one in. I've not decided. But let's have a look at the circuit board. So here's my circuit board I'm going to be using. It's a brand new old stock FR4 fiberglass from Radio Spares. It is about, more or less, exactly the same size. It might need a little bit of filing out in places, like there. I might have to file these odd little bits out to make it look the part, screw holes. But as you can see, it's well manky under there. So that's the plan anyway. I'll just talk you through the valve holders and then we'll stop the video, and then I'll continue this at home over the bank holiday. So let's just talk briefly about these valve holders and what's so special about these. Well, these are actually screened valve holders. If you look, like, there's a metal spigot in the middle there. Now this is more important over here in the IF stages than it is on the audio amplifier. But the reason you can't put an ordinary one in them, the screening is very, very important. If you look under there, it's actually earthed. Now that pin through there, that actually screens all these individual pins, but the actual screening is carried through this circular disc into the base of the valve itself, so it's screened from the pins right up through to the valve. Now if we take a look at these, that is a screen holder, and you can see the spigot at the bottom, and this one here, this doesn't have the screening in. Now what I'm going to do is I'm going to just stop the camera and look out an old valve, and I'll explain how this actually works in the middle. Right, okay, so I've found a Duff EF80 just to explain how the screening works. Now you can see the internal screen there, so I've drawn the EF80. Now if we take the valve base, in the bottom of the base you've got that circular disc, which is actually there. You can just see it in the middle, and that comes through to the bottom. So you're screening these pins, but you're also screening the pins that go up into the valve. And how that works is as follows. When I get the camera in the right position so I don't drop it. So if you look in the bottom of the valve holder, you've got that metal disc which is there. Now in the valve itself you've got the screen there, and that comes out to a round disc sitting in the bottom of this valve, which is there. So you can see what happens now when you plug that valve into that base. It actually forms a capacitor, and the dielectric of the capacitor is actually the glass here of the valve. So when we plug the valve into its base, we formed a capacitor between the disc in the bottom of the valve holder and the disc in the bottom of the valve itself. Now you can't probably see it in there. The metal disc actually sits in that hole, which sits over the top of this hole here to form the capacitor. I think what I'll do is I'll stop the camera and I'll just break this open so we can extract that disc and have a look at it. Right, so that's the valve broke open. Now this will become more clear why it's so important. So if you look in the bottom of the actual valve, you can see the round bit in the glass, and if we look at the underneath the valve, that is the round. Let's see if we can get this into position. That's your round disc in there. So when the valve plugs into there, the round disc forms a capacitance between there and there, with the glass in between. So I haven't got very good lighting in here, but no. Yeah, well, you can just about see it's not, the lighting's not that good, but you can see it better there. So that is how this valve is fully screened, because that sits on top of there with the dielectric of the glass forms a capacitance, and that screens this valve right from top to bottom. And that's why it's so important that we're going to have to fit either new valve holders with a screen, or I might, if I can't find any in my stock, I might have to just ultrasonically clean the old ones and fit them back in. But anyway, I'm going to stop the video now, and then over the bank holiday I'm going to carry on with the video. I'm going to strip everything off the board, take every single component off till we've got a blank board. Now there's many different methods of making a new printed circuit board. I'm going to show you something that's different. I've used this quite a few times. It's very successful. I don't think anybody on YouTube will have ever used this method before, so this might be a first, but I'll show you a completely different way of making a brand new circuit board. Right guys and girls on YouTube, it's bank holiday, my wife's gone out, I've got the house to myself, I can spend all day doing electronics, so we might even be able to finish the circuit board in a day. So that's the old circuit board. I've removed all the components off it. As you can see, it's very burnt in places. That'll be where the audio output valve is. That's the back of the circuit board. I've removed all the parts. You can see some of the tracks are lifting. And some places where the track's lifted, I've actually drawn the track in with a black felt tip pen to remind me what it actually looks like. You can see more bits there I've drawn in. Now I don't see any problem making this. The biggest problem is going to be drilling the holes for the valve bases. Because they like elongated, it's not just a hole. But anyway, that's the old circuit board out of the radio. That's the new one. If we put that on top of there, it's virtually the same size. We're just going to have to trim a little bit off there and there to make it fit. So the first thing now is to get this out of the packet, rub it down with some wire wool, and then we can start making the circuit board. And I'll show you in a minute how we're going to actually make this circuit board without a picture of a magazine that we can etch straight from. Right, okay. The first method in making this circuit board, you can see that beautiful piece of FR4 fiberglass. What I'm going to do is I'm going to overlay that onto there, and I'm going to drill just a couple of holes, one in each corner, so I can actually bolt this down onto the top of the fiberglass board. Right, so with my trusty Black & Decker vintage drill, what I'm going to do is I'm going to drill the first hole in the corner and drill it straight through that. Actually, one thing I forgot to say is we need to clean this circuit board. That's very important, and I'll show you why in a second. Right, so actually that's the board cleaned up. You can see now the charring in the board from the audio output valve and the rectifier valve. So anyway, I've got a first bolt on. It's the smallest one I've got, but it doesn't matter because you'll see what it's for in a minute. I've just got to drill another hole in there and put another bolt through. Right, so that's the old board clamped to the new one. I've marked where to cut off. Now what I'm going to do is a little drill. I'm going to drill out every single hole through here so it comes out on the back of the fiberglass board. Now I'm not sure how I'm going to get the valve holders back in yet because these aren't circular holes, as you can see, but we'll figure that out later. So let's start drilling all these holes out now. Right, and this is why the board has to be clean, so we can put masking tape on. I've sectioned it off so we can do a small bit at a time. There's 18 small holes to drill first, so I've sectioned it off. We can count them holes as we're going along so we don't miss any. Right, so you get the idea now. If I hold that up to the light, you can see the 18 holes I've drilled. We turn back to the board. That's the 18 holes. So what we do now is section off another piece and drill the rest of the holes. So we'll come back to this when I've drilled all the holes. Right, so that's the finished result. If we turn over, you'll see all the small holes are drilled. Now it's absolutely essential you don't miss a single hole, and that's why I've taken so much care over the drilling, because all will become clear in a few minutes what'll happen if you miss a hole. But as you can see, I hold it up to the light, and that's all the holes all drilled through. Right, so we just peel this off now. I've got to drill out for the valve bases next. Right, so after deburring we should have something that looks like that. Now here's the last chance to check every single hole has been drilled through. Otherwise, if you don't, we've ruined it. Right, so that's the finished result. That is the new circuit board made out of FR4 fiberglass. Right, next thing we do is we clean all this copper with steel wool and acetone, or nail varnish remover if you want. Right, so as you can see, I've roughened up the surface of the board with some wire wool. I've cleaned it with nail varnish remover. You can see all the dirt's come off. That is absolutely pristine now, because you don't want any oil or grease or fingerprints. I've given my hands a wash and some solvent. The next thing you need to do is get yourself a brew, because we're going to be here quite a while now, and what we're going to do is we're going to draw all these tracks on here using indelible markers, and for the thick ones nail varnish, and we're going to draw all these by hand using these holes as reference points, a bit like making a dot to dot picture. So I'm not going to do it live on camera. I'll do a few. I'll show you what it looks like, and then we'll come back when it's all finished. Right, so that's how we do it. The thick tracks I'm painting on with nail varnish, and the thinner tracks I'm just going to put in with this indelible marker. So we're about halfway through now. Another couple of hours it should be finished, and then we'll get etching. Right, so that's the new board. You can see all the tracks marked on it, some in indelible ink and some in nail varnish. I've checked it against that, it's all correct. I've just got to make a couple of little adjustments to these tracks where some are a little bit close, and then we're all ready for etching. Right, so that's the board ready for etching. I don't know how well it's going to come out, but there's one important thing to mention before you start. Don't forget to sign up your board. I don't know if this will come out. It might even etch off that, but we'll give it a go. Right, let's get the etching kit out then. Right, so I've just borrowed the washing up bowl out of the kitchen while there's nobody in. The ferrite chloride's been warmed. Let's get etching then. Right, there we go. An absolutely perfect fit in the washing up bowl. So we're underway now. Right, if you have a look at that, that's still sitting in the ferric chloride, but it looks like the etching's nearly done. That's at about 12 minutes in some warm ferric chloride. So I'm just going to pop it out and take a quick look, because we don't want to overdo this. It actually works a lot quicker, ferric chloride, when it's warm than when it's cold. Right, there we go. So just into some cold water now to neutralise it. Right, so that's the board now in some cold water. The only thing remains is to get the washing up bowl cleaned out and get it back in the sink before my wife gets home, and then we'll clean this this board up with acetone, see what it looks like. Right, and there we go, and that is how you make a new PCB without the artwork. And it did actually come out there, I didn't etch that bit off. So that's the board signed. All we've got to do now is get some brand new parts and start populating this new board. Let's just take a look at the other side. There we go. Very nice. Right, so I think the population, we're going to have to stop the video now, and the population is going to be another day. We're going to have to come back to this. Right, so that's the progress so far. I've not cut these bits off the board yet. I've got most of the resistors on. That one's not soldered yet. And if you look at the diagram, I'm ticking the parts off as I'm putting them back on the board. So that's the progress so far. We'll carry on fitting some parts, and I'll film some more bits to this video yet. Right, so that's all of the resistors on. I've marked them all off on there. It's the other ones left of the dropper. I've decided to keep these capacitors. They've all cleaned up. I've tested them all. They're all alright. They're all like tubular ones. These don't look like tubular, but underneath this paint they are actually tubular, which I've found in the past are very, very reliable. So I've decided to keep all them. So there's just a few more capacitors to fit here, and then what I'm going to do is I'm going to cut and shape this board, and then we'll start putting the bigger things on, like the valve bases and the IF transformer. But as you can see, it's coming on. I'm making quite a bit of a mess up here in the loft. This will all have to be tidied up when it's finished, but yeah, it's coming on. Let's take a quick look at the back. I've also decided to reuse the valve base, so I'll clean all them up and put them back on. But that's how we're going so far. So we'll come back in a bit, which will actually be in the video, probably another few days. We'll come back in a bit when some more bits are on. Right, so that's all the valve holders on. I've actually used the old valve holders. I've just put them in an ultrasonic cleaner and cleaned them up, and they look perfect. So the only thing now to go on is the two IF coils and the smoothing capacitor and reservoir capacitor there. Now I've actually measured the value of the old one. It's 35 microfarad, it should be 50. So it is down in value, both sections, so I'm going to have to replace that. I don't know whether to just put two ordinary caps in, or whether to drill out the centre of the old one and put two new caps in to make it look a little bit more original. But I've not decided that yet. The next thing to do is get them IF coils on. So that's the build so far. Actually, I've just remembered we've got to get the oscillator coil in as well, which actually goes in them 4 holes there. Right, so I've just cleaned up one of the IF coils. I've only done it by hand with a bit of degreasant. As you can see, that's an old one, and that's the one I've cleaned up. Now I haven't cleaned this in case I rub it off. I've just cleaned round the numbers because I want to keep them on. But if you look at the top, it's very, very dirty, and then you realise when you've cleaned it, there is a white mark on this, and the other one has a different coloured mark. So it's important you get these in the right way round. So the white one goes towards the audio output valve, with the writing facing towards the audio output valve, like so. So all I've got to do now is clean up that one, and that should reveal a different coloured mark to that one. Right, so that's the first one on. Let's clean up the next one, get that fitted. Right, so that's the other IF coil, and that indeed does have a different colour mark. That's a blue mark, so it is important which way round these coils are fitted, and that one will fit there with the writing towards me. Right, so that's the last IF can on. The only thing we've got left now is the local oscillator coil there, and then actually the board's finished. And there we go, that's it, all done, finished. Apart from, of course, the reservoir capacitor and smoothing capacitor, which I'll make a decision about that in a few days. Right, now I can't find a cap that will exactly go into that space, and I'm not going to drill any more holes. So what I've decided to do is refurbish the old cap. Now I've hollowed it out already, as you can see, and this is what's going in the middle. Some brand new capacitors in that hollow can. But in doing that, I've also rubbed off a little bit of the writing. So what I'm hoping to do is to write that back on with an indelible marker, and perhaps put some sellotape round there to protect it. So that's the plan. New caps inside the old can, and then that will go back onto there like that. Right, well, I'm not going to film too much footage today because my nose is blocked. I've got a lousy cold, but I'll just show you the progress so far. The bore's all fully populated now. I've got the valve bases on, the oscillator coil, the 2 IF coils. I've rebuilt the capacitor. I've added the writing on it, but it's not very good. And I've covered this in sellotape to protect it. So that's the new board, that's the old board. All I've got to do now is add some wires onto this. I've sprayed the underside with a lacquer to make it nice and shiny, as you can see. So that's the progress so far. I'm just going to add, for today, I'm just going to add some wires on here, and then I'm going to call it a day for today. But yeah, that's where we're up to so far. That's the new board, all fully populated now. Right, so I brought this to work with me to test because it's a lot safer testing it here. It's all assembled, but there is one thing I've noticed, a slight error I've made on the circuit board, which I've actually corrected now. Yeah, there it is. I've actually missed out this RF screen. It's just like a little loop there connected to earth, and it screens these two tracks. So what I've done is I've just soldered a piece of wire in, as you can see there, and I'm just going to spray some lacquer on it to hold it down. Now the original fault, I've had this radio running, but the dropper was faulty. I just managed to strap some on the end. So what I'm going to do is I'm going to do the same now, just so I can test it out and see if it works before we go any further. So let's just turn it over with better lighting here so you can see what it looks like. And that's it. That's the old board. That's the new one. Right, so I've just got to strap, that's fault. Two sections on that faulty actually, which is unusual. I've just got to strap a drop onto there and then I'll try it. Right, so the radio works fine. I've just tried it. I've come up with an idea to replace the dropper, but I've got to order a part from somewhere in Germany. So I thought, well, we'll do that while we're waiting, because it might be another 10 days or so. We'll just do a bit of refurbishment on the cabinet. Now obviously the top one's polishing, but I'm masking it off now, ready to repaint the front. And I thought the best thing to do, rather than try and mask this off, I've actually removed this dial, which wants a bit of a clean anyway. I've rubbed that down. We'll glue that back on after. I'm just going to repaint this front first. So that's the next bit. We'll come back to that when the front's finished, and then hopefully the part will be here from Germany, and we'll carry on with the rebuild. Right, so that's the cabinet all masked up. That's the paint I've got, which is, well, it's almost an identical match that. Let's get this on then. Right, so that's the finished result. That's all painted up. I've cleaned the dial, that's ready to glue back on. The actual cabinet, I'm going to leave that to last. I'm not going to polish it now and risk it slipping through my hands and dropping it. I'm going to polish it when it's all finished. Right, so the next thing to talk about is this dropper, which is actually faulty. In fact, very unusually, there's two different sections on it faulty. Now, I haven't got one of these. It's going to be impossible to buy one, but I've come up with a plan to replace it. So let's just take a look at the resistance first. Let's just do a bit of mathematics on the figures. Right, so to make this a little bit easier, I've just redrawn the heater chain, the rectification and smoothing onto a bigger piece of paper, so it's a bit easier to look at while I talk you through it. Right, so these are the four sections of the dropper. You've got R2, 100 ohms, 3 watts. That's actually the surge limiting input resistor for the rectifier. You've got two resistors here that actually form the heater chain, and you've got a little tap, which is that, which you can pull off and put it onto the next section, and that for 220 to 250 volt we run the heaters through two resistors, and for 200 to 220 that's shorted out, that resistor, and we just run the heaters through the 850 ohm 9 watt resistor. And then of course the output of the rectifier, the cathode, you've got the reservoir capacitor, you've got the 600 ohm 6 watt HT smoothing resistor, that's also part of the dropper, and the smoothing capacitor on the output. So there's actually 1, 2, 3, 4 parts to that dropper. Now let me show you what we're going to do. First we're going to work out what dissipation there is in the heater chain, and I'll show you how you do that. Right, so using a valve data book, what we do is we find out the heater voltage of each single valve and we add them all up. Let's see what the total is. Right, now actually my maths isn't that good. I have to do everything with a calculator. So that gives us a total heater chain of 126 volts. Now the valve data says the heater current on all these valves is 100 milliamps. Right, so the mains in 230 volts. We need to take 126 volts from 230, and that gives us with 104 volts. So we need to drop 104 volts across. Where's my diagram gone? We need to drop 104 volts across these two resistors here. Tell you what, let's just work out the power dissipation before we carry on. Right, so assuming the link's open, we've got two resistors in series, 850 ohm, 250 ohm, that adds up to 1100 ohm. Right, so the power dissipation of them two resistors is going to be the 100 milliamp times the voltage we want to drop. So it's 0.100 times 104, and that gives us 10.4 watts dissipation in these two resistors. Now that's actually quite a lot, especially to have in such a small cabinet. And then we've got the dissipation of all the valves as well, and that's why these radios run so warm. So what I've come up with a plan is we're going to actually change these resistors for a capacitor, and we're going to use the capacitive reactance to actually drop the AC voltage. So let's just do a quick calculation on that. Right, so that's the piece of board that's going to go sit on top of there, and I'll drill a hole in there to get the capacitor straight through that. Right, there we go, a little bit of shaping so it fits down around various places. So that is going to sit there. If you look at this, it's very rare for vintage radios to have a fuse fitted. So what I'm going to do is I'm going to put a fuse here as well, and maybe even have space to mount it on that board. Right, so that's the circuit board all ready for etching. That's the fuse holder I'm going to add, and for greater reliability I'm going to parallel resistors up. So where we've got 600 ohm for the HT smoothing, I'm going to be using two 1.2Ks in parallel, and for the surge limiter 100 ohm I'm going to be using two 200 ohms in parallel, and these are 5 watt resistors, so that will effectively give us 10 watts each. So that's the original fitted was 6, we're going to have a 10, and the original fitted there was a 3. We're going to have a 10 watt resistor there as well, and put a fuse on the incoming mains, so that should increase the reliability. So I'll stop the camera now and I'll finish that off at home tonight. Right, so that's the other part of the dropper on the circuit board. As you can see, I've had to put the fuse underneath because when the capacitor's sitting on top of there, there's going to be no room for a fuse. But it's alright underneath. I've lacquered this with PCB lacquer as well. That's all ready to fit now. Right, so while we're at it, I think I'll change the mains wire and plug as well. But I've just spotted one last job to do, and that is I'm going to change that capacitor there as well, for greater reliability. But that's the new mains wire. Right, so now what we need to do is we need to simulate the heater value resistance drop of 1100 ohm with a capacitor. Now actually the maths for this quite complicated. Maths isn't my strong point, so I'll show you a quick way that seems to work for me. So we've got to replicate 1100 ohms using the reactance of a capacitor at 50 Hz. Right, so the capacitance value we need is 2 times pi times f, which was the frequency, times xc, which is the capacitor impedance, and that's the value that we need that we're going to simulate the 1100 ohms dropper. Right, so it's 1 divided by 6.284 times 50 times 1100. Let's just calculate that out. Which is 1 over 345,620, which gives us a capacitance value of 2.8933. So let's just round that up to 2.9 UF. Now, of course, because of the 90-degree phase shift in the capacitor, this value isn't actually right, and there's a lot of complicated maths to get it right. But as an approximation, now we've got this value, I find if you just divide it by 2, that will give you the value you need. So 2.9 divided by 2 gives us a capacitance value of 1.45 microfarad. Now obviously you're not going to get a capacitor of that value. The nearest one up, we're going to round that up to 1.5, which will be the nearest preferred value. So what we want now is a 1.5 microfarad capacitor, ideally a motor run one, or the type that use in fluorescent lights. Right, so that's what we've got so far. We've got the capacitor in series with a heater chain. Now normally with a wattless dropper you'd have a surge limiter resistor, a minimum value of about 100 ohms in series with this, just to stop any switch on surges so we don't blow the valve heaters. Now instead of wasting another resistor, instead of connecting a 100 ohm resistor from there to there and wasting another resistor, I'm actually going to connect this point here onto that side of the surge limiter for the valve. So these resistors now are providing surge limiting for the wattless dropper and the valve. Now when this when you turn this off, that capacitor will remain still charged. So just for safety, we're going to add in a resistor across there of 680k, and I'm going to use a 1 watt metal film for greater reliability, so it doesn't go open circuit. So that is our revised heater chain, and here we have a picture of the finished article. That's the capacitor with the 680k on top. That's the rest of the ballast resistors, obviously, like I said before, paralleled up. There's just one final thing to do. That's the fuse underneath. I'm going to look for a little plastic cap to go over there just for safety. But one final thing to do that I've forgotten is this capacitor here. We're going to change that. Now I'll probably not get one as big as that, but I'll find a way of replacing that anyway. So that's the final job, and then all it wants now is reassembling all back into the case. So the case has now been repainted and polished. I've just repainted the pointer on there, and we're just down to the reassembly now. Right, so that's the replacement capacitor in there. I know it's a bit over the top putting a Mullard mustard in, but it does fit quite nicely. And just before we start reassembling, I'm just going to do one more modification to this. Right, so the very last thing I'm going to do to this radio before we start reassembly is the sound on these is very tinny. It's a lot of treble and it lacks bass. And I don't think the plastic cabinet helps either. So we're just going to introduce a very small negative feedback loop. Now what I'm going to do is the live end of the speaker here, the speaker at the end that's not grounded, we're going to take a wire from there and we're going to put a 68 PF capacitor from the live end of the speaker straight into pin 1, the grid of the UCL82. I'll just mark it on 68 PF. Now obviously, because that's the grid is the input, that's going to be very sensitive. So we've got to solder the capacitor as close as possible to pin 1, the grid. And this lead here that goes from here to the live end of the speaker, that's also going to have to be a screened lead, and the screening of the lead will connect to the other side of the speaker because that's grounded. Now I've already included that mod. I'll just show you, I'll see if I can show you what difference it makes. So here we have the screen lead, and you can see it comes down there. That's the 68 PF capacitor soldered straight to the grid. I'll cut a bit off there, but for demonstration purpose I'm just going to hold this and touch it on there, and you can see, well, I don't know if you'll hear the difference on YouTube or not, depends how good the audio is, but I'll just see if I can demonstrate that first before I solder it permanently.
You've been thinking, isn't it? Now you may want to call Anita on any answers on this one. Before you do though, here's Helen Keane.
Freshly roasted Arabica beans, super sugary iced coffee from a supermarket.
Right, so I've just listened to the video, you can hear it on the camera. So that's it then, we're all finished. That's a little bit of bass boost introduced. You can see there I've got the wires as short as I possibly can because it's the grid to the triode, and it's earthed at this end here with a black wire, the screen lead. So right, all we've got to do now is just the reassembly. Right, so one quick thing we'll talk about before we wrap this video up and I'll show you working is the electrical safety of this radio. Now obviously these are AC/DC sets, so it has a half-live chassis, there's no mains transformer, and that means these two metal controls are actually connected to the chassis. So just as a quick demonstration, I tap on there and I tap on the neutral, and you can see we have a direct connection to the neutral. Now the way they insulate these from the user is these two grub screws. There's a metal grub screw there, and that actually goes through the hole first, and that is what's responsible for holding this knob on. And then after you've fitted that, there's a little brown plastic one and that goes in the very last, and it's the plastic grub screw there that insulates from the metal, so there's no way you could actually poke anything down the hole or touch any exposed metal. So when you reassemble this, it's most important that you check you've got the plastic grub screw in very last. Right, so one last check. Let's just check the heater voltage. I said we needed all the valves added up together, 126 volt. We need 126 volt at this point. So let's see what we've actually got. That's it. And we've got 121. So we're only actually 5 volts out by making an approximate calculation with this capacitor, which I don't think is too bad. And just to show the plastic grub screw and there doing its job, we'll do an insulation test. And as you can see, no electrical breakdown at 500 volts. So that's absolutely perfect. Right, so let's take a quick look at the finished result. Now, the reception in here is absolutely terrible, so we'll only get 1 or 2 strong stations.
Oh, but that's not happening. Okay. As Emily stated, they're not looking at this critically.
Verity, let me talk about performance if I could, because John Dutton said there is a performance advantage. And that is very hard for women who were born as women to take if they are in competition against trans women. They think it's just not a level playing field.
Yeah, and what we're talking about is what is a level playing field in sport, otherwise we'd all be exactly the same. So we've already got sports people out there who are celebrated for their genetic differences, but trans people are being looked at as different because of them being trans, and talking about this height, weight, overarching. Play women that were 6'4" and 20 stone, and that's okay. We're still seeing that within lots of different sports. And
against him, it's been a good year.
I mean, doesn't it? I mean, let's be blunt about it.
Well, what matters in sport is the body you have. We don't know what is in anyone else's mind, but we can absolutely see who turns up.
A kidnapping conviction won't make up for that. No. No, of course not. Tony might believe a court case will give us justice. I can't see how we're ever going to get that.
Oh, I'm glad I caught you, Susan.
Oh, Oliver, did you forget something?
I just wanted to...
You're lucky. I was just bringing the...
Alright guys and girls on YouTube, that's the Philips B2G81U from about 1958-1959. The only thing I need to finish it off now is the Philips badge that's missing on the front. And I do have another one of these radios knocking around somewhere, so I'm going to have to look for it. The Philips badge, and of course there's one screw missing from there as well. Alright everybody, many thanks for watching my channel, and I'll catch you in the next video. Goodbye.